So our learning goal today really is being able to write and solve proportions. So you already are familiar with, in fact, some of you said you did use proportion models to help you problem solve on the problem solving worksheets for today. For using a proportion model, when you have 3 givens and you need to find one unknown, the proportion model is a really good method for helping you problem solve. I use proportions a lot when I'm problem solving, okay? So, while a proportion is made up of ratios though. What's a ratio? It's a comparison of 2 quantities by what operation? What's going on in a ratio? Remember, it's a comparison of 2 quantities, so it is actually a fraction. And what's going on in fractions?
Division.
Division. Yep. There's a comparison of 2 numbers going on, and we could divide them out. In fact, that's what Josh just said he did. He figured out that 60 cookies divided by 24 cookies was 2.5. So we knew that the recipe had to be taken times 2.5. Okay. So the comparison, let's talk about our ratio being A and B. The 2 quantities that are going to be compared are going to be A and B. So the comparison of A to B could be written as, we can write it as A to B with a colon between it. Now, does order matter in division?
Yes.
Well, if order matters in division, does order matter in ratios?
Yes.
Yes. If they give us the ratio of something, we have to keep that order. If they say they're comparing 2 things and they compare it, they've already made the comparison for us, we have to keep the order that they give us. What's another way we could write it? This is one way, 2 with the word 2 in it. And now we said colon. What's another way we could write it? As a fraction. Yeah, as a fraction. And when we see it written as a fraction, there's something that we should say to ourselves, you know what? B cannot equal something. What can't B equal? What can't you divide by? No, you can divide by A if you have 1 any old time in the world, but not in this case, we're not dividing by A. What can't B be? Okay? 0. We cannot divide by 0. So in our ratio of A to B, B cannot be equal to 0. The denominator can never be 0. If it is, there's nothing going on there that we can talk about. It has fallen apart. A statement that 2 ratios are equivalent. What's equivalent mean? Equal to each other. A statement that 2 ratios, so 2 fractions, right, equal to each other. What's that called? A proportion. Yeah, that's, as Andrew said, I set up 2 fractions and set them equal to each other. So if we have 2 ratios set equal to each other, we actually have ourselves a proportion. Okay, well there's an important math property that says if you have A over B, or A compared to B, equal to C over D, or in other words, C compared to D, if you have that relationship and B does not equal what? What can't the denominator be?
0.
0. And D does not equal
0.
0 because it's a denominator also in that case. As long as neither of those denominators are 0, then what can we count on with the cross products property? So it's basically saying if you have a proportion, a true proportion model with no 0 denominators, you should be able to multiply a numerator times the other denominator, and then that leaves the B to be multiplied times the C. So cross products. Oftentimes when we're simplifying multiplication of fractions, we think we're doing this, we're doing cross products, we're not. We are dividing out common factors when we're simplifying multiplication of fractions. This is not multiplications of fractions. This is a fraction equal to another fraction. And we can say that the products of the numerator, opposite numerator and denominators are equal to each other. So this could also be written D times A equals C times B, because does order matter in multiplication? No It does not matter in multiplication. Okay, well I believe last year as 8th graders, you probably did not use cross products to solve proportions, am I right? Okay, what did you do? What did you do, Deb?
We would have divided 8 by 2 to figure out what 2 times something
Yeah.
equals.
So in other words, you'd have to figure out what would you have to do to 2 to get 8? And what would you have to do?
You have to take it times 4.
You'd have to take it times 4. Well, if you're going to multiply the denominator times 4, you also have to
Multiply the
Well,
numerator.
so basically what you're doing is you're renaming a fraction to be equal it's just giving it a new name. So in other words, negative 5 halves, one of its new names is x over 8. But we gotta know what x is. So what would x be in this case? Negative 20, because negative 5 upstairs times that 4 would be negative 20. So negative 20 over 8 is the same as negative 5 over 2, right? Okay, well, now when we're getting into, like algebra and we want to be able to use proportions to help us problem solve, sometimes it's not so easy to be able to figure out what do you have to do to rename this fraction, such as, can anybody tell me what we would do in this one right next door? G plus 3 over 5 equals 7 over 4. Any ideas what we would do there? How could we rename? Basically, it looks like we need to rename 7 fourths, don't we? As thirds. So we got to figure out what would go in there for G. I think they know. Did you have to do anything like this with them last year? Anything? Okay. So this is where the cross products property comes in handy, because you know what? We say, well, what times 5 is 4? Oh, I don't know. And then I got to take G times 3 upstairs times that same thing to get 7. So there is something times 5 that gives you 4. Anybody happen to know what it is? What is it? It's 8/10 actually. It's 8/10. But we're going to use cross products, and we're going to see this is a whole lot easier than we have to deal with there. So since we're going to use cross products when we have that situation, let's just start using it all the time. Okay? So we're going to take the first numerator times the opposite denominator, the other pair, the other denominator and numerator times each other. So we're doing what we call, oftentimes you'll see this, cross products. The factors become a numerator and the other denominator, then the other numerator and the other denominator. Well, this becomes what over here, negative 5 times 8?
Negative 40.
Negative 40. And 2 times x? 2x, right? What would we do next? Divide both sides by 2. So negative 40 would get divided by 2. 2x would get divided by 2. And sure enough, x equals what?
Negative 20.
Negative 20. So you already knew that. So we just proved that the cross products property works, right? Did we just discover that it seems pretty trusty?
Yes.
Okay. Well, since it's pretty trustworthy, let's try it then on the next one. We're going to take G plus 3 times the 4. Does order matter in multiplication? No, so let's do it like this. Let's put the 4 out front, and we're going to, because this is going to be really, really important. Here's what I'm going to see on paper, so I'm going to have to say incorrect word. If you write it like this, that first product, that would be incorrect. Can anybody tell me why that would be incorrect? Austin?
You parentheses around the G and the 3.
Why? Why do I have to put those parentheses there?
Because you have to multiply 4 times G and 4 times 3.
Yeah, in this case, only the G is getting multiplied by 4, isn't it? Only the G is. I would multiply 4 and G together, and then I would add 3. So this would become 4G plus 3. I have to put that numerator in parentheses, okay? When it's more than one term, more than one piece to it, I have to put it in parentheses. Well, now we have to take the other pair times each other, so 5 times 7. Okay, go ahead and solve that because you know how. You need to simplify first. You need to do your distributive property first. Anybody have a solution yet for G? Okay, what do you have, Adrian?
I got G equals 5.75.
Okay, he has G equals 5.75, 4, 5, and 7,500. What do you have, Andrew?
G equals 5.75.
Okay, you have the same thing. Okay, anybody have something different? Oh, you all like that. Is 5.75, does that have other names that possibly might be in an answer bank, Devin?
5 3/4.
5 3/4, that might be shown as 5 3/4 in an answer bank. What other way might it be shown in an answer bank? This is algebra. Remember, algebra likes sometimes to just leave your answer. What do you think?
5.75 on 100.
No, they probably wouldn't do that because that could be simplified. 5 3/4. What do you think, Josh?
G equals 23 over 4.
Yeah, sometimes they'll just leave it like that. So we have all kinds of options here. 4 does not go into 23 nicely, so they might show the answer like that. Or they might divide it out and say, you know what? Or change it to its mixed number name and say, here's its mixed number name. Or they might divide it out and say, here's what happens when I divide it out. 3 names for the same value, right? They're all just different names. And again, we have to make sure that we understand that the way we get our answer isn't always going to be how it's displayed in an answer bank. Okay? Did we expect that we would get maybe what you might want to call kind of a weird number? In other words, we didn't get a whole number. Why did we why would that seem reasonable to expect that? What do you think? Anything that might say, you know what, I don't really feel like this is so unreasonable. Devin?
Lost it.
Okay. So remember up here when we were saying, how are we going to figure out what we have to do to 5 to get 4?
That's what I was thinking.
Yeah. We couldn't come up with it. We didn't really know for sure what should we do to 5 to get 4, but then I said, well, how about multiplying by 0.8? Okay. So that's why it doesn't seem unreasonable that we didn't get a nice whole number or integer answer. Okay? Questions at all? So you get to start using cross products property. If you choose not to use cross products property, such as like on this one, you're like, you know what, why would I use cross products property on a problem like that? If you don't use cross products property, then show me what you are doing. What are you doing then? If you're taking 2 times 4 to get 8, you would show that. You would say, you know what, here's what I'm doing. I'm taking 2 times 4 and I got 8. I'm going to take negative 5 times 4 and that's how I'm going to get x equals negative 20. Okay? You still show me your process. Okay, let's go to the back side then. Okay, as I said, proportions are wonderful for problem solving, but here's the deal. What students do, they're a little bit too haphazard sometimes when they're setting them up. You have to have a good setup to get a reasonable answer, okay? And again, we should always make sure our answers are reasonable. So carefully set up your comparisons. Now I need everybody to hear me on this. Are you with me, Brady? Everybody needs to hear me on this. When we are setting up our proportions for these word problems to problem solve, we are going to use labels with our numerators and denominators. So you're going to have this proportion that has more than just numbers in it. So let's do this first one. The ratio of games won to lost. Here's the deal, folks. It matters the order that they are talking about. So you might want to circle that, underline that, star that, something. Highlight it if you have your own highlighter. Come up here and get a highlighter from me if you want one in that basket, whatever. The ratio of games won to lost. So in other words, the numerator should represent what? Games won, and the denominator should represent
Games lost.
games lost. For a baseball team, it's 5-3. So we're going to go right to this. We're going to write down our first ratio. 5 won to 3 lost. And I don't care how easy this problem seems. We need to just get in the habit of even when they're easy, do this so that you set yourself up for success when they're not so easy, okay? Well then, if that's that case, it says if the team has won 70 games, how many have they lost? So what would our other ratio look like? What would our next ratio be? be looking like? Austin, what do you think?
70 over X.
71, right? We're gonna put labels in our proportion, just our setup, okay? 71, and you wanted X? Okay, X were lost. So now we have a proportion to solve. We can use cross products, or we can use the other method that you like. You can figure out what times 5 gives you 70 and multiply the numerator and the denominator by that. So go ahead, solve this. Now you don't have to keep your labels in while you're solving, but in the end, when you get your answer, you're going to give a label to your answer. What'd you get for X? What'd you get, Kate?
42 lost.
42. So 42 games lost, okay? And here we're going to insert the word games too. 42 games lost. But before we move on to the next column, we're going to say, does my answer seem reasonable? And give me some reasoning why you think our answer is reasonable. And don't say something about because we did the calculations right. Yeah, of course we did. We're good. Austin?
Because the amount won was more than the amount lost, and 71 is still more than 42 lost.
Yeah. So in the beginning, in the ratio that they told us, they're higher than 500, right? That's what we say. They're more than 500. They're winning more than they're losing. So in this, we better have less games than 70, right? They're losing less than they are winning. They're winning more than they are losing. So that seems reasonable. Okay, let's do one more. The ratio of the sale price of a jacket to the original price is 3 to 4. So again, this is important information. Ratio of the sale price to original price. So in reality, we want to keep that order so that it makes sense when we line our labels up. So the 3 is 3 what?
3 over 4.
3, this would probably be dollars, right? And this is the sale. And then the 4 would be labeled dollars, and this is the original. Well, then they ask, if the original price is $64, what's the sale price? So what's our other ratio going to look like? What's the other ratio going to look like? Andrew?
X dollars and then the label would be sale.
So we're looking for the sale price.
And then $64 and the label would be original.
Okay. So we have to make good comparisons, in other words. You can't switch up the comparison in the other ratio. If you're comparing sale to original in the first one, compare sale to original in the other one, right? Okay, go ahead and solve that. Whichever way you decide to solve a proportion showing your work. Are you going to use cross products, or are you going to just rename the fraction? So what do we do for X? What do we do for X? Devin?
$48.
$48, okay. And what is that again? Is that the sale price or the original?
The sale.
This is the sale price, okay? $48. We can put $48 on sale. How's that?
Yep, that's it.
Okay, does that seem right?
Yes.
Yes.
Okay, because, Devin?
Well, it was a 3 to 4 ratio, and now it's like 48 is smaller than 64. So.
Wouldn't we expect the sale price to be less than the original?
Yes.
I would hope so, otherwise please don't shop there. How many people, along with the store sale, would have if you guys charge more on, for the items on sale?
Not very long.
Yeah, not very long. Very be like, ha ha, okay. Okay, so again, what are we gonna do when we're doing these word problems? We're gonna put labels in your ratios, in your proportion setups, and I do want you to set up proportions to problem solve, okay? Because I'm going to be giving you some problems that come along that you're gonna be like, this will be, being able to set up proportions is gonna be like, make your problem solving so much easier. So any questions? Okay, then I'll let you get started on your homework.